Okay, so we're continuing with 8.3 scientific notation. Now, this is, I'm going to say, this is adding and subtracting. Before it was multiplying, dividing, and I introduced scientific notation to you. The one thing I didn't do is when I assigned homework last time, I left off number 10 and 12, if I'm not mistaken.
I remember you said that made you mad.
Yes, it made me really mad. So, yes, I don't know why I did that. I don't know why I left off 6 or 8. I really don't understand why I did that. No, but we've got to understand it. So I'm going to go back and real quickly, let's look at 2.54. This is just like a recap, times 10 to the 8th. And we want to put that, bless you, into standard form. That means take it out of scientific notation. Okay, now remember, if the exponent is positive and we want to put it in standard form, it means take it out of here, then your standard form is not going to be a big ugly, right? So we're going to move the decimal right 8 times. 1, 2, 3, 4, 5, 6, 7, 8. And you got to be careful when you do this, because if you start putting zeros all over the place, you'll get a wrong answer. You put a 0 only in those little hoops. And then you rewrite the answer 2, 5, 4, and then there's 1, 2, 3, 4, 5, 6. 6 zeros. 1, 2, 3, 4, 5, 6. And there is the answer in standard form. Do we recall this?
Yes.
Hopefully you're utilizing the IXLs. There's other links I have on my proto page that I'm not going to assign, but you can also do those to help you prepare for the test that's coming up. Any questions about how to take that number and put it into standard form? Cecilia? Well, I'm about to show you. I'm about to show you one. Michaela? Okay, so let's do another one. So that's one example. This is a recap again of what y'all learned. Today's Wednesday. Monday?
Yep.
Monday. This is a repeat of Monday. So let's say it's 1.53 times 10 to the negative 4. And again, we want to put it in standard form. Okay, that means the standard form, we're taking it out of scientific notation, and we want to bring it back to its regular number. If we have a negative, then the regular number is probably going to be a big ugly. So if I have 1.53, this time I'm moving the decimal to the left. Up here it's positive, so I'm moving it to the right. This time it's negative, and again that's taking it out of standard form, scientific notation. Yep, exactly. Standard form looks like that. Standard form's about to look different here. So it's negative 4, so I'm going to move it 1, 2, 3, 4 places to the left. I'm putting a 0 in each hoop. If you get sloppy, you're going to get a wrong answer. And my answer is 0.000153. You can put a 0 there to make it look better. But notice there's no more decimal here. Just like there's a decimal between the 2 and 5, it's gone. because you took it out of scientific notation. You put it into standard form, like a regular number. And then here it's a negative, so we want big ugly. Big ugly is negative. So the standard form for that would look like that. So you had a question? Oh no, we don't deal with that. Any other questions? All right. So let's get started on adding and subtracting scientific notation. Now y'all did the color sheet yesterday for the multiplying and dividing. You've got IXLs and everything, so now we're gonna move on. And I have very few notes for this, but you better pay attention. So when adding and subtracting, there are specific rules here too. Multiplying and dividing, I feel, is a little bit easier because you're multiplying the two regular numbers, and then the 10 with the exponents, you're just applying the rules of exponents. The bases are the same, you're multiplying, so you add them together, and then you can adjust that number to be into scientific notation between 1 and 10. Dividing, same thing. You're dividing the number, make sure it's between 1 and 10. And in that case, being that the bases are the same and you're dividing, then you're subtracting the exponents. Yes, sir?
Is the adding subtraction going to be kind of like how when we were learning the other thing, we had the different groups?
A little bit. A little bit. We're taking the grouping that you're talking about, but there's a very specific rule to adding and subtracting. So pay very close attention. And if you've been doing your IXL and studying this stuff, today will not be hard. Very important information here. I'm putting 2 stars. Before adding or subtracting, numbers in, so you're taking notes, you're supposed to be in the front. In scientific notation, Cecilia, move to the front. Make sure that both numbers are expressed using the same power of 10. Multiple exclamation marks. Before you add or subtract numbers in scientific notation, make sure both numbers are expressed using the same power of 10. Basically, exponents have to be same. Before you do anything, exponents have to be the same. You better write that down. You underline what I underlined. You put what I put in parentheses. So before we do anything, we got to make sure the exponents are the same. If not, then we need to make some adjustments, and that's where things get hairy.
You're stopping.
That's right.
That's right.
Emily, you got it? I can't see you, so I'm just checking over there. All right, so you got it? Here's another 2-star component. It is usually easier to rename the number with the lower power of 10 to match the higher power. It's easier to rename the number with the lower power of 10 to match. Basically, it's easier to rename the smaller. Rename smaller exponent to match higher exponent. This is Mrs. Rogers' trick. Everyone got it? All right, here we go. I don't have a whole lot of examples, so pay attention. Once I start showing you examples, you're going to be like, oh, okay. But if you need more examples, you need to say something. So watch this. 2.3 times 10 to the 6th power plus 5 times 10 to the 6th power. Write that down. Okay, so what, Emily, is the rule when adding and subtracting scientific notation? What do we have to have with the exponents? They have to be what? The exponents, when adding and subtracting in scientific notation, the exponents have to be what? What's the rule? We just wrote it. Look at your notes. The exponent, that's right. The exponents have to be the same. When adding and subtracting scientific notation, the exponents, or the powers of 10, have to be the same. Are these the same powers of 10, Emily? Then we can go ahead and do regular adding and subtracting. Taylor, you're going to be paying attention here. Don't pretend to shoot Aiden. All right, so just like multiplying and everything, we're going to group. The first thing you check, again, before adding or subtracting, make sure the exponents are the same. Okay, before adding or subtracting, the exponents are the same. Oh, look, they're the same. So now we're going to group. Just like when we were multiplying. So we're going to group 2.3 plus 5. And it's plus 5. Well, I'm going to put a little arrow because we're adding. If we were subtracting, we would have a minus sign here. And then I'm going to say times 10 to the 6th power. Guys, when we are adding and subtracting, the exponents have to be the same, and then we just bring them down. There's no work to be done now. You don't add 6 plus 6. You don't multiply 6 times 6. You just bring it down. Emily, you with us? I can always look on y'all's faces and I can tell when y'all zone out, just so y'all know. Even with masks on, I can tell. Okay, so we don't do anything. They're the same, so we just bring it down. So 2.3 plus 5, remember the decimals have to be lined up. We get 7.3 times 10 to the 6th power. Now, Cecilia, is this number between 1 and 10? So we're done. Between 1 and 10. There we go. That number checks, we're done. Now, if all of them were that easy. Any questions about this? Let's do another. Y'all ready? Yes, Abe.
So if one of them has a negative exponent and does the other one have to have a negative exponent for it to be negative?
They have to be exactly the same. I mean, like, exactly the same. That was a good question. He said, what if it was like a negative 6 and that's a positive 6? Well, that will not be the same, so you got to adjust it. And I'm about to show you how to adjust it. So, that's not too bad. Now, let's do one where we have to make some adjustments. So, you really have to pay attention here. 5.4 times 10 to the 5th power minus 4.7 times 10 to the 4th power. Oh no. Michaela, what is the important rule before we do anything when we're adding and subtracting scientific notation?
That the exponents are the same.
That's right. The exponents have to be the same. Cecilia, are they the same? Oh no. These are different. Oh no. They have to be same.
Oh no.
Oh no. They're different. So, if you remember what I said, oh my goodness, yes, Eddie?
I have, but I think I have a question on how you do it.
Well, can I show you?
Well, I want to see if I'm right.
Oh my gosh.
Would you move, like in the parentheses, would you move like 4.7? Would you move that to the left because then you get times 10?
Okay, maybe.
Okay.
So, back over here, I said it is usually easier to rename the number with the lower or smaller exponent to match the higher exponent. So, here's our lower one. We're going to change lower or smaller exponent to match higher. So we're going to change that lower exponent to be 5. Emily, what are we changing this 4 to? There you go. So let's work on that. I'm going to write 4.7 times 10 to the 4th power. Because I'm just rewriting it to fix it. Now, Aiden is correct. We need to make this 5. So I need to add 1 to it to make it 5, correct? And he said, well, then you would move this decimal to the left 1 place. If we're going to add 1, we got to move this to the left 1. So then, because that's the rule. So then it's 0.47 times 10 to the 5th power. We added 1, so we move it to the left 1. You better have those arrows on your notes. And now I have 0.47 times 10 to the 5th. So now our exponents match. So I'm going to rewrite my problem. 5.4 times 10 to the 5th power minus, now my new number here, my new scientific notation, 0.47 times 10 to the 5th power. Before I move on, are there any questions? If you are always moving or changing the lower number, now those of you that may be confused, listen carefully. If you're always changing the lower one and you add, you will always be moving it left. If you're like, how am I going to remember? I don't remember that rule. Well, this is stuff that we talked about on Monday or Friday last week or something like that. But you always will move it to the left. Always move it to the left because we're adding. That's why I said it's easier. So now we do our grouping. 5.4, and we're subtracting this time, so minus 0.47 times 10 to the what, Cecilia? To the 5th power. Very good. Because when you're adding and subtracting, once you've made them the same, you just bring it down. So then over here, I have 5.4 minus 0.47. We got to put in a little 0 there. And we end up getting 4.93 times 10 to the 5th power. Wit, is this number between 1 and 10? So we are done. Any questions about how we do adding and subtracting? Just remember, you first check, if the exponents are the same, you go ahead and do your work. If they're not, move the lower exponent up to match the other one. And you can't just turn it into 5. You have to move the decimal left that many places. If I was going to add 2 here, I would move it 2 places, right? Of course I'm going to do another one. Any questions?
Should I just write this out?
Everyone have this? Not right now.
It's the next
All right.
page. It's the next page.
Open your book to page 341. Just keep going. You don't need to rip it up. Or you can. But see, the thing is you should be writing this and opening your book.
This was the next page.
Page 341.
I'm already there.
Good. Looking, make sure everyone's got their book open to the correct page. 341.
That's on 342.
Okay. We're going to look at number 19. All right. I have 4.3 times 10 to the third power plus 5.2 times 10 to the third power. Michael, after you have that written, tell me, what is the rule when adding and subtracting scientific notation? Have to have the same exponents. Are these the same exponents? Yes. They are same exponents. You better be writing these arrows in my little notes in red. Because then if you have to go back and look at your notes, you'll see all these little things. And they will help. And your notes should be nice and neat, especially since I give you all the time you need. Okay, so these are the same, and you're like, yay, good, okay. So what do I do now, Michael? Yeah, so we're grouping. That's going to be 4.3, and we are adding. So I'm going to add here 5.2 times 10 to the what, Michael? That's right, to the third power. We don't do anything to it. And then, Michael, what is 4.3 plus 5.2? 9.5. Michael, is that number between 1 and 10? Yes. And you're done. Make sure it is between 1 and 10 before you box it. Otherwise, you'll have to make adjustments. Any questions? See, this isn't so bad, is it? Once you start getting through the scientific notations, then things start clicking. When you're done writing notes, please put your pencil or pen down so that I know that's Cecilia. So I know that you're done. All right. 21. Any questions about 19 before I move on? All right, here we go. 2.8 times 10 to the 9th minus 3 times 10 to the 7th power. Okay, I'm going to pick on Emily again to redeem herself. Emily, what is the rule when adding and subtracting scientific notation? They have to be the same. Good job. Are these the same?
No.
These are different. Oh no. Have to be same. So, Emily, what do I need to do to get them to be the same? Okay, but which one? Which one do I need to change? Which exponent should I change? Bingo! Because remember I said we want to make the lower one match the higher one. What do I need to add to the 7 to make it, match the 9? Huh?
Is it 2?
Yes, don't overthink it. So I'm going to rewrite my problem right here. She is correct. We're going to take this one, the lower exponent, and we're going to mess with it. We're going to get it to match this 9, so she's correct. We're going to add 2 to get it to be 9. But if I'm adding 2 here, Cecilia, what do I need to do with the decimal in that 3? Which direction? That's right, that way. Now, boys and girls, this is a whole number. Your imaginary decimal is going to go right here. We're going to move it 2 places to the left. put a 0 there and decimal. So now I have 0.03 times 10 to the 9th power. And if you want to go ahead and put a little 0 there, you can. Before I move on, any questions as to what we did? Took the smaller exponent, like Emily said, and we want to match it to the higher one, so Emily said add 2. She's correct. And Cecilia's correct. We're going to move that decimal then 2 places to the left. And here's our new scientific notation. Any questions? Yes.
How come, what do we do, because it's not between 1 and 10?
We're not, we haven't subtracted it yet.
Oh.
So this is okay if it's not between 1 and 10 because it's not our final product.
Oh, okay.
So now I'm going to rewrite, that's a good question, my problem with my new number here, 0.03 times 10 to the 9th power. So now they're the same. So then I do my grouping because I fixed all that. I am subtracting. Please be careful. I don't want you to accidentally add instead. And then we just bring down our 10 to the 9th power. Don't have to do any more work with that. So we need to line up our decimals. And Gabby, what do you get? That's right. Times 10 to the 9th power. And Taylor, is this between 1 and 10?
Yep.
So we are done. Any questions? This isn't too bad, is it?
Nope.
Always moving it to the left. All right.
Question.
Yes.
Do you think it would still work if you took it out of scientific notation and did it and put it back? That would be stupid, but probably would it do.
I'm sure it would.
Let's do it Miss Rogers' way.
Oh no, he can do it his way. If you get there, there's multiple ways of solving math. Okay, so today y'all are doing numbers 10, 12, 20, 26, 28. Last time y'all did 52 and 54 and stuff like that, right?
You went
Yes.
50 through 58, right?
Yeah.
Even.
Yeah, we can't do that.
Be nice. Okay, so that's those 5 there. And then honors, what did y'all do also?
We did.
We did 36. Oh, wait, no. We did 36 and 38.
Oh yeah.
What is this?
You know what? I'm feeling generous.
Yay.
This is all you have to do.
Really?
What?
Really, really. It is due Thursday.
Thank you.
And your IXL, you can work on that when you're done. That is due Friday. And you have a math test coming up. I can't remember when I have that scheduled, but I will put it on the board inside and outside and proto page and everywhere else.
Can we choose what subject that does word searching?